A manufacturing firm produces two machine parts, A1 and A2. For this, it makes use of milling and grinding machines. The different machining times required for each part, the machining times available on different machines, and the profit on each machine part are as given below. A. Formulate a linear programming model for the problem. B. Present the model in its canonical or standard form. C. Using the Simplex method, determine the number of pieces of A1 and A2 to be manufactured per week in order to maximize profit. We have a table here for the machine column, the manufacturing time required in minutes, and the maximum time available per week. So as you can see from the table, maximum means less than or equal to. So that's the maximum. You can't exceed the values given over here. So just as we did in our previous two videos on linear programming models, I'm going to skim through the solution since we have been through the question A and B before, and our main focus is going to be on the Simplex method. So for the A part, we represented our x and y's. We got our objective function 7x plus 100y. We wrote down all our constraints just as given from the table. 5x for the machine time constraints, the milling machine, the grinding machine, and the non-negativity constraint. For the B part, we listed out our constraints again, but this time in the standard form. So you can realize that we now have our slack variables being represented. So from the first constraints, we are having S1, that is the first slack variable or the slacking variable, S1. The second one, we are having S2, and the third equation, we are having S3. And then in the maximized equation, we are having 70x plus 100y plus we have S1 and S2, S3 all being represented, but you have a coefficient of 0 in the maximized equation. So let's move straight ahead to our Simplex tableau, or using the Simplex method. So in the Simplex method, we're going to draw out a very beautiful table to represent our constraints and also our objective function. So let me take a minute to explain everything on this table. So on this column, we have the bases. So the bases, we have S1, S2, and S3. That is being represented by the slacking variables. Then in the CBJ, we have the coefficients of these slacking variables. So if you see the maximized equation here, we have 0s1 plus 0s2 plus 0s3. Now these zeros are the coefficients of the slack variables. So that is the coefficients you are writing here in this column. And at the x part, we also have the values for x, that is 5, 4, and then 1, just as given from the constraints. The same thing goes for the y, and the same thing goes for the s, that is s1. Now s1 has the value of 1 and 0 in all other places. The same thing goes for s2. It has a value of 1 as s2 and 0 any other place. The same thing for s3. Then at the solution parts, we have the maximized value, which was 1500, 1000, and 750. We talk more about the ratio as we go along. Now let's give a little focus to the slacking variables or the slack variables. Now if you look at it properly, you can see that we have an identity matrix. What is an identity matrix? An identity matrix is a matrix that has the value 1 running through its diagonal and all other places having the value of 0. So if you look here, you can see we have an identity matrix for the slack variables. Now whenever a value has, or a variable has the value 1 or has the coefficient being either 1 or 0, we call it a basic variable. So you can see S1 is 1 here, and it is 0 in all other places. The same thing for S2, and the same thing goes for S3. So this is what we call a basic variable. It has the coefficient of 1 or 0. Now if you look to the left of it, which is the XY column, you can see that the same thing cannot be said for X and Y. That is, the X and Y's are what we call non-basic variables. Alright, now down here we have the CJ minus ZJ. Now this is the row we call the net evaluation row. To get the values on the net evaluation row, there are some calculations that we need to follow and some instructions that are given along with it. So how do we get ZJ values? Now you can see that its initial values are all zeros. Why are they all zeros? They are all zeros because the coefficient of the objective functions is 0, 0, 0. And we get this zj by multiplying the coefficient of these objective functions by the corresponding column. So if I want to find the value at this 0, it's going to be 0 times 5 plus 0 times 4 plus 0 times 1, which gives me 0, right? I come back to find y is 0 times 15 plus 0 times 6 plus 0 times 3, and that will also give me 0. So I do the same thing for all the columns, and it's going to give me 0 throughout. Also, to get the values at the net evaluation row, which is cj minus zj, what you do is that you take the value at the top from the objective function. That is, you take 70 minus this zj value, which is 0, and gives you 70 here. You go to the top, you take 100 minus the 0 here, and that gives you 100. You take 0 from here minus this 0 on the zj, and that gives you 0. So you are doing a subtraction between this top value here and the down value over here to give you the net evaluation row. Now that we've gone through everything on this table, now how do we use the simplest method and what rules govern it? So let's do that. Now to start with the simplest method, what we do is that we look on our net evaluation row and look for the maximum positive value. If you look closely, the value that is positive and has the highest value is 100, and the 100 is on the y column. So since the value is 100 and it's on the y column, that makes y the key column. Now the big question is, why are we taking the maximum positive value from the net evaluation row? Remember that the whole point of the simplest method is to make sure that all the values on the net evaluation row are either 0 or negative. Currently, we have 170, so you're going to take all the positive values from the net evaluation row, right? So that by the end of our calculations, we should have only 0 or negative values on the net evaluation row. That is why we are taking 100, which is a very big value from it. Okay, so as I said, the y is the key column now. Now another instruction from the simplest method is that once you find a key column, you must also find a key row. Now I'll explain why we need a key row and a key column. Now to find the key row, you go to the solution, you pick a solution and its corresponding value on the key column. So 1500 has its corresponding value on the key column, which is y, to be 15. So you divide the solution 1500 by 15 to get 100. You do the same thing for 1000. You take 1000 divided by its corresponding value on the key column, which is 6, and we get 166.67. Next, you take 750 and find its corresponding value on the key column, which is y, the value 3, and you divide it and you get 250. Now to choose which of these is going to be our key row, you look for the value that is positive but also the lowest. So the lowest positive value, which is going to be 100. So this 100, which is our first row, becomes our key row. Now we know our key row and our key column. Now the key row and the key column intersect at the value 15. So 15 becomes a pivot. Not to confuse you with the words, we have a key row and a key column. Where they intersect becomes our pivot. In this case, 15 is our pivot. What is going to happen next is that we are going to swap the key column, which is y, with the key row. So we swap y with s1. So the value y, which is 100, is going to move to where the s1 is and replace it, and s1 will move away. Alright, now let me go through some instructions here. We know that our pivot is 15. Now we are going to perform what we call row operations. Don't let it confuse you. As you go along, you get used to it. Now with the row operations, what we want to do is that we want to redraw this table to perform some iterations. Remember from the beginning, I told you that our main goal is 2. Our main goals are 2. One is to make the net evaluation row zeros or negative values. And the next thing is that we want to make these x and y values basic variables since they are non-basic variables. So how do we make this 15 here 1? Another instruction is that on this row, we are going to divide all the values on this row by 15 so that the value at the y column becomes 1, right? And then all the values that are either above this 15 or below it must all become zeros, just like we have it for the basic variables, right? So the 15 is going to be divided by 1, and then we make sure that the values that are below the 15 all becomes zeros. So S1 here has to be 0. On the S3 row, this 3 has to also become 0. Again, we are making them basic variables. So let's do that. So let's begin with our row operations. So we are going to multiply row 1 of the matrix A by 1 on 5. That is, we are dividing all the values on row 1 by 15. So if you do that, we are going to get our new row 1 to be 1 on 3 1, 1 on 15 0, 0 100. Right, you can do this on your calculator. Then next, as I said, the values that are below the 15, they must all become zeros. So to get that, we are going to take the row 2 minus 6 times the new row 1. This is our new row 1. And our row 2 is this way. So to perform the calculations in green, you can see it over here. I have all the values for our row 2 down here. 4, 6, 0, 1, 0, 1000. We are multiplying by 6, so minus 6, 6, 6. You can see 6, 6 here. And then the values for our new row 1 are the ones in the bracket. So I perform the calculations over here. And I come back here to input the values. So you have 2, 0, negative 1, 0, then 400. Right? So you can do it this way as I have it here in green. Write down all the values for row 1. Minus 6, then put it in brackets, new row 1 equals, and you get your values. Now you may be wondering, why am I taking 6? You can see from down here that since new row 1 has the value at 15 at y being 1, and the value down here is 6, I can do 6 minus 6 times 1. That's going to make the value y here 0, right? The same thing over here. If I take 3 minus 3 times 1, I can get down the S3 y value down here to be also 0. That is what I'm going to basically do. So the same thing for our new row 3. I take our 3 minus 3 times the new row 1. So in the green, I have all my row 3 values here, and then minus 3, and then all my new row 1 values in the brackets, and I'm going to get these values. So I come back here to input my values. So from these new row 1, new row 2, new row 3, I'm going to redraw my simplex tableau. In my second tableau, you can see there are some major changes. The first change is that I have replaced all my new row 1, new row 2, or I've filled in my new row 1, new row 2, and new row 3. And the major change again is that previously we had an S1 value here. Now we have a Y value, which is 100. The S1 was 0, but then remember that we replaced the S1 with Y, which had a value of 100, right? So the only thing you may be wondering right now is, how did I get these values down here at the ZJ and then the net evaluation, which is the last row over here? So let's go through that. To get my ZJ values on this row, down here is the calculation, and also for the net evaluation rule. So let's go through it. I started with 100 times 1 on 3 plus 0 times 2 plus 0 times 0, which gives me 100 on 3 as I have it here. Then on my net evaluation rule, I'm going to take the value from the top, which is 70 minus this value 100 on 3. That gives me 110 on 30. Alright, so remember, we are multiplying the values on the bases, this basis, with the values in each column. So we take the basis here and multiply by the value in each column. So let's go for the next one, the y column. The same thing, we have 100 times 1 plus 0 times 0 plus 0 times 0, that gives me 100. And then on the net evaluation rule, I have 100 from the top minus 100, that gives me another 0. Then we can go to the column S1, 100 times 115 plus 0 times negative 0.4 plus 0 times negative 1 on 15. That gives me 20 on 3. Now when I do the calculations at the net evaluation row, that's going to be 0 minus 20 on 3. That gives me a negative value, which is negative 20 on 3. Then for S2, the same thing. I do 100 times 0 plus 0 times 1 plus 0 times 0. That gives me 0. And 0 minus 0 is 0. On S3, 100 times 0 plus 0 times 0 plus 0 times 1. That gives me 0. And 0 times 0 minus 0 is also 0. Then at the solution part, I have 100 times 100 plus 0 times 400 plus 0 times 450. That gives me 10,000. Alright. Now, remember that our main goal for the Simplex method is to ensure that all the values on the net evaluation row are either negative or 0. But in this case, that is not it. Over here, we have the value 110 divided by 3, which is not a negative value or equal to 0. So, how do we do that? We are going to pick that value and its column. So that becomes our key column, right? The next thing to do is to find our key row. And remember how we find our key row? We go to the solution, pick the value element at the solution, and then take its corresponding value on the key column. In this case, 1 on 3, 400. And you do the same for 400. 400 divided by its corresponding value on the key column, which is x, so that here becomes 2. So 400 divided by 2. You pick 450 divided by its corresponding value on the key column, which is 0. Alright, so you're going to get 300, 200, and then undefined, which is the dash values here. Now between 300 and 200, obviously 200 is the positive lowest value. So that becomes our key row, right? Now the intersection of our key row and our key column, the value there or the value element there becomes our pivot. So 2, which is the intersection of these rows and columns, becomes our pivot. And since this is our key column, the value there, which is x, is going to replace the value on our key row, right? So that means that x is going to replace S2. So the value 70 will replace the 0 down here. Alright. So as I said in our previous table, once you have your pivots, you need to perform row operations so that you make the x values basic variables. I explain what basic variables are. So how do we make the 2 value here a basic variable? We are going to make the 2 to be 1 and the value on top of it or below it to be 0. In this case, we have the value below 2 to be 0 already, meaning we don't have to do anything to that row. But the value on top of the 2 is 1 on 3, so we have to change this 1 on 3 to 0. So let's perform the row operations to ensure that 2 becomes 1 and 1 on 3 becomes 0. So let's do that. So computing for zj and cj minus zj. On column x, we are going to do 100 times 1 on 3 plus. Now you're multiplying all these by 0, so they are basically equal to 0, and we're going to get 100 on 3. Now that we have 100 on 3, to find our net evaluation value is going to be 70 minus 100 on 3, which is equal to 110 divided by 3. I think we've gone through this before, alright, so let's go to how to perform the row operations to get to our values. So with the row operations, as I said, we are going to divide through the key row by 2 so that we can make the value to 1. So when we do that, it's going to be our new row 2. 1, 0, negative 0.2, 0.5, 0, and then 200. Alright. So if you also want to know how we had the net evaluation row 2, I have the calculations on top here. You can take your time to go through it. And then to find our new row 1, remember that we are not dealing with new row 3 because the value down there is already 0. So we are not dealing with this value here. Okay. So since we want to find our new row 1, to get that, we are going to take the old row 1 minus 1 on 3 times the new row 2. So that's going to be 1 on 3 minus 1 on 3 times 1, which is going to make it equal to 0. Alright, so if you look on the right here, you can see I have the calculations in green. That is 1 on 3 minus 1 on 3 times 1, which is equal to 0. So I have all the values for R1, that is our row 1, all from 1 on 3, 1, 1 on 5, 0, 0, 100. Minus, now we have 1 on 3, and then the new row 2. The new row 2 is the one top here, so we have 1, 0, negative 0.2, 0.5, 0, and then 200. And I do the computations, and I have the value 0, 1, 2 on 15, negative 1 on 5, 0, and blah blah blah. So this is our new row 1 and new row 2. Remember, the row 3 is not going to change because the value that was under the 2 was already 0. Okay, so remember, for basic variables, they have 1, and any other value on that column has to be 0. Alright, so I'm going to draw out my third tableau. So my third tableau, you can see that I have filled in my new row 1 and my new row 2, but the row 3 did not change, it remained the same. Okay, so we're going to go through the same iterations again, right? And remember, we swapped the S2 value here with the X, right? That is why it is now 70, not 0, because you swap the S2 with the X, which is now 70. So we're going to perform the iterations again. 100 times 0 plus 70 times 1 plus 0 times 0, that gives us 70. Now 70 from the top minus 70 from here gives us 0, right? And 100 times 1 plus 70 times 0 plus 0 times 0 gives us 100. Right, the same thing goes 100 times 215, 70 times 0, negative 0.2 plus 0 times this gives us this value, and then you subtract 0 from the top here, that gives us this value. So we do that for all the columns. I don't want to do that because we've done that already. Alright, now when you are done and you look at the net evaluation row, remember our goal is to ensure that all the values on the net evaluation row are either 0 or a negative element or a negative value. But you can see that on the S1 column, in the net evaluation row, we have the value 2 on 3. Now 2 on 3 is a positive value, right? That means we have to take it away from the net evaluation row. So we are going to make this S1 here our key column. Now the next thing to do is to find our key row. Now how do we find our key row? To find our key row, we are going to go to the solution side and take the value at the solution side divided by its corresponding value on the key column. So you're going to take 100 divided by 3 divided by 2 divided by 15. Okay, so 100 on 3 divided by 2 on 15. That will give us 250 as a ratio. The same thing, 200 divided by negative 0.2. That's going to give us negative 1000. And lastly, 450 divided by negative 1 on 5, and that gives us negative 200 and 250. Okay, so you take the value at the solution side divided by its corresponding value in the key column. Okay, so amongst these three values, the lowest positive value is 250. Now the intersection of the key row and the key column occurs at 2 on 15. That means 2 on 15 are pivots. And this key column, the value which is S1, is going to replace the value at Y, which is on the key row. So the key column is going to replace the key row. So Y here is going to be replaced by S1, which now is going to make the 100 0. So now that we know our pivots, with our pivots, we are going to perform row operations so that we can make this a basic variable. So what is a basic variable? With a basic variable, the 2 on 15 has to become 1, and all the corresponding values on that column must be 0. So this negative 0.2 and negative 1 on 5 must all become zeros, and this value here becomes 1. So now let's perform that row operations to make it a basic variable. Let's do that. To get our new row 1, we are going to divide all the values on the row 1 by 2 on 15, and that's going to make the S1 value here 1. And that's what we are going to get: 0, 7.51, negative 5.40, 250. The next thing to do is to make the value under it 0. So how do we do that? We are going to take the row 1 plus 0.2 times the new row 1. How do we do that? So since S1 here is 1, if I take negative 0.2 plus 0.2 times 1, I'll get 0. So that is how I did it. So I come here and say R1 plus 0.2 times new row 1. And I list out all the values for R2, that's 0, 2, 1, 0, negative 0.2, 0.5, 0, 200. Plus, and I have all my 0.2s. And then in brackets, I have my new row 1, the values for all my new row 1. And I do the computations. And I get these values and I show them in my new row 2. So you can see that just under the S1, I will have a 0 there now. Okay. Then I will move to the new row 3. Again, I want to make the value there 0. So if I take negative 115 plus 115 times 1, I'm going to get that place to be 0. Right? So again, I list out all the values for my row 3 plus 15 and all my values for new row 1. And then I do my computations. I come back here, fill it inside my table, and I'm going to get 0, 1.50, negative 0.251, and then 500. So you can see that we have 100. Okay. To do next is to draw my tableau from this new row 1, new row 2, new row 3. I'm going to draw out a new tableau. So let's go there. In a new tableau or fourth tableau, I have filled out my new row 1, row 2, and row 3. And you can see that the value here has changed, right? We now have S1 replacing the value Y. So S1 has the value 0, okay? And then the only thing now left is to do my calculations for ZJ and then the net evaluation row. So I'm going to leave that out to you to perform that calculation to see if you're actually getting what's going on. So as you know, it's the values at the basis column times the column that you are looking for. So 0 times 0 plus 70 times 1 plus 0 times 0, that gives me 70. Then 0 times 7.5 plus 70 times 1.5 plus 0 times 1.5. That gives me this value here, 105. And then you subtract the 70 from the 70 here, the 100 from the 105 here. The same, you do the calculation, you get 0, 0 here. You subtract them, you still get 0. You get 0 times negative 514 plus 70 times 0.25 plus 0 times negative 0.225. And then you do that, you get 17.5. When you subtract from the top, which is 0 minus 17.5, and you get negative 17.5. So here you get 0. And then the last solution here to the same thing, 0 times 250 plus 70 times 250 plus 0 times 500, and you get 17,500. Now if you notice clearly, you can see that in our net evaluation row, all our values are actually either 0 or a negative value. Do you realize that we have negative 5 and negative 17.5? So it means that we have finally gotten to what we wanted. You see, we wanted all the values on our net evaluation row to be either negative or 0, and they are now. So you can see that we have now gotten to our destination where we can have our optimal solution, right? And you can see that we have some basic variables here, 0, 1, 0 here, 1, 0, 0 here, right? For some of our values. So from here we can see that this is the final simplest tableau for the model, since all the entries in the CJ minus ZJ, that's the net evaluation row, are non-positive values, right? So the optimum solution for the model is Z is equal to the value we have here, which is 17,500. Then the value of S1 is 250. Remember S1 from here. S1 is 250. X, the value for X is also 250. And the value for S3 is also 500, right? The remaining values are all 0. That is Y and S2 are all zeros, right? So this is a very simple method to find for our optimal solution, guys. If you have any questions, leave it down in the comment section. As always, I'll be willing to reply.